Okay, moving along. Let's now look at linear equations that have fractions within them. And in particular, we're going to find the do's and don'ts of dealing with equations with fractions and generating points. An equation with fractions, let's say we had y equals negative 1/2 x plus 1. And I want it to generate a table of values. Let's go ahead and take out our calculator. And talk about making a table of values for this. So I'm going to type the equation 1/2 x plus 1, negative 1/2 x plus 1 into the calculator. So I start with typing negative, then to make a fraction 1/2, you would just use division. So I would use 1 divide 2 and then x plus 1. Now let's go to the table. I'm gonna delete all this. Okay. Look what happens when I type the number 1 and enter. I get a decimal. I get 0.5. And if I were to type 2, I get 0. Now I'm going to continue with the next consecutive integers. And I want you to notice a pattern. When am I getting integer y values and when am I getting decimal y values? So notice for the odd x's, I'm getting decimal y values, and for the even x's, I get whole number or integer y values. Integer meaning it's not a decimal. Okay. Now why is this happening? What's going on? So whatever x value you insert into this x, it's going to multiply to 1/2. When you take 1/2 and multiply it to an odd number, you're going to get some kind of decimal number. So for instance, 1/2 times 3, I get 1.5. 1/2 times 5, I'm getting 2.5. So this always happens when you take 1/2 and multiply to an odd number. You're going to get some kind of decimal as a result. If I change this to even, then I'm going to get an integer as a result. So for instance, 1/2 times 4 gives me 2. Or 1/2 times 10 gives me 5. So I'm getting these nice round integer results. So my advice to you is when you're dealing with equations and fractions and you're trying to generate a table of values because you're going to graph something by hand, avoid x values that give you decimals. Okay, now why? Why would we avoid that? What's so wrong about a decimal? So think about the xy plane that you'd be drawing your graph on. Not every xy plane is accurate to show you a decimal location. This particular x-axis actually does have 0.5 markings on it. Okay, and the y-axis as well. Okay, this isn't always the case with every set of x-y axes that you have to draw something on. Sometimes you have to guess where the 0.5 location is going to be. Okay, so to just avoid the guessing, we just try to avoid getting y values that have decimal results. So in this case, if I wanted to graph y equals negative 1/2 x plus 1, and I generate my table of values, I'm just going to focus on only using x values that give me integer results. And it just makes graphing a lot easier when you have to do this by hand. So let's look at a different fraction. Let's say we had to graph negative 1/3 x plus 1. Okay. By hand. We'll go to our table then. So now look what happens if I type 1, 2, 3, 4, 5, and 6. Now notice the pattern. I'm getting decimal results for certain types of x values, and I'm getting nice integer results for other kinds of x values. So the key here is you have to look at the fraction and its denominator. In this case, the denominator is a 3. So if I want an integer result to emerge as a y value, I'm going to want to make sure that the x I input is a multiple of the denominator. In this case, a multiple of 3. So notice on the table that on my calculator it says 3, 0. So 3 is a multiple of 3. And then down below at 6 for x, which is a multiple of 3, I'm getting a nice integer result of negative 1. Okay, so if I just want integer results in this equation, I'm just going to want to type numbers that are multiples of 3. So see that? These are all multiples of 3, and I'm getting nice integer results. And this goes for any fraction. So let's say we had a different equation. Let's say we had a 2 over 5x plus 1. Can you now guess what are going to be the x values that you put in here into this equation so that you get integer y values as a result? So hopefully you're gonna guess it's the multiples of 5 that give us integer results. Okay, so let's go ahead and change our equation on our calculator. Okay, 2/5 x plus 1. We'll now go to the table. So notice the only x value currently on this table that's a multiple of 5 is the 0. Okay, and that's giving me an integer result for y. And all these other numbers are not multiples of 5, and notice I'm getting decimal results because of that. Okay, so go ahead and erase everything here. So then if I just choose multiples of 5 like 10, 5, 0, negative 5, and negative 10, notice the y value is always a nice round integer result. And I would be able to graph this with ease. Okay, so for instance, if I want to plot 0, 1, I can easily find it on my axes, 0, 1, and put a point on there. Now compare that with what if I had used the x value 2? Then I would have to figure out where on the axes is 1.8 for y. And I wouldn't want to bother, okay, because that's just gonna ruin my chances of making a nice graph by hand. So I wouldn't even consider trying to graph that. Not unless accuracy is not the focus, okay. But since I want to be accurate, I'm just going to stick with these other choices. So negative 5, negative 1. And now I have my graph, my 2 points, and now I can connect them with my line. And there it is, a nice accurate graph where we relied on integers instead of decimals. We'll now look at how to find the intercepts of a linear equation. So the intercepts are where the graph crosses the x and y axis. Okay, so let's just pull up a blank axis here. So I'm just gonna give us some kind of line, and our intercepts are this point and this point. Okay, so when it crosses the x-axis, we call this point down here an x-intercept, and I like to just write x-int for short. And this point right here we call the y-intercept. So these are points, right? They have an x and a y coordinate. Now just by the fact that it's on an axis, we already know half of the information that would go into the ordered pair notation. Because it's on an x-axis, the x-intercept will have a y value of 0. And the y-intercept, because it's on the y-axis, the x value at this location is 0. This tells us something then. In general, x is always 0 when you're at a y-intercept, and y is always 0 when you're at an x-intercept. Let's take an equation, y equals 2x minus 5. And we want to find the intercepts. Okay, so to find the y-intercept, we're going to let x be 0. Because we said earlier that when you're on the y-axis, x is always 0. Okay, so let's insert a 0 into our x in this equation. And then we're going to calculate and get our y value. So 2 times 0 minus 5 is minus 5. So that means the location of the y-intercept is 0, comma negative 5. Okay. Now let's look for our x-intercept, and we're just going to do the opposite. Okay, to find the x-intercept, we're going to let y be 0. So same equation, y equals 2x minus 5. We're going to put a 0 into the y. Now we're looking for the x to make this equation true. So in this case, we have to get x by itself. In other words, we have to solve for x. So I start with adding the 5 over to both sides. So 0 plus 5 makes 5 equals 2x. And then I'm going to divide both sides by 2. And now I have my x value. It says here x is the fraction 5 over 2, which is also the decimal 2.5. I would say then that the x-intercept as a coordinate is 2.5, comma 0. Okay, so there's our intercepts. And this is what you always do when you're asked to find the intercepts of an equation. It's a two-part process. You're going to let x be 0 to find the y-intercept, and then you're going to let y be 0 to find the x-intercept. We'll end this lesson with a special case of linear equations. So we've been looking at equations, linear equations of the form y equals mx plus b. Now we're going to look at equations where it's y equals a number or x equals a number. These are two separate types of equations. Let's start with y equals 5. So y equals a number, and I just chose 5. So how would we graph this? What this really means is that every coordinate on this graph is going to have a 5 as a y value. And then what would the x's be in this case? Well, these will just be any number. Okay, so it could be, let's say, 2 comma 5. It could be -1 comma 5. It could be -5 comma 5. As long as the y coordinate is always 5, that's what would satisfy this equation. Because that's what this means. It just means that y is always 5, no matter what x is. Okay. So now let's look at a graph. And what we're going to do is graph the equation y equals 5. Okay. Well, I generated some points earlier. Here's my points, 2 comma 5. So we'll go ahead and plot 2 comma 5. -1 comma 5. And -5 comma 5. Notice a pattern is emerging, where every point that I plot is lining up with all these other points in a horizontal manner. And notice any point that has a y coordinate of 5 is going to fall in this horizontal pattern. All of these have y coordinate 5. So that means the graph of this equation is a horizontal line. So this would be the graph of the equation. And this is going to happen for every other kind of equation of the type y equals a number. So what about equations that are x equals a number, like x equals 2? Points for this graph would just be points where the x coordinate is 2, and y will be any number. Okay, so we can have points such as 2 comma 1, 2 comma 0, 2 comma -3. Now let's go ahead and plot these and see what kind of pattern emerges. Okay, so 2 comma 1, 2 comma 0, and 2 comma -3. We're seeing a vertical pattern. And that's exactly what the graph of this equation is going to be like. It's just going to be a vertical line through these points. And this is going to happen for any equation x equals a number. Okay, so if I had an equation that said x equals -2, I'm just going to have a vertical line that goes through -2. Okay, so just a final note about calculators and graphing. So today we graphed equations of the form y equals mx plus b, and we said these are going to be the graph of lines. And so notice on a TI calculator it's set up so that it says y equals. So the only types of equations you can graph on a TI would be those that are solving for y. Okay, so basically every equation in this video we were able to input into the TI calculator, and also the two special case equations at the end of this video, we saw that an equation like y equals 5 is going to give us a horizontal line, and you'll see that on the TI calculator. So if I were to graph, you'll see it generates a horizontal line. Okay, and the table of values will have always a 5 at the y, because that's what the equation says. It says y is always 5 for any x value, and that's how we get a horizontal line. And then we also saw vertical lines, right? Like x equals 6. Okay, this is going to give us a vertical line. However, you can't generate that on a TI calculator because of the way it's set up. It's only going to take equations of the form y equals. So you won't be able to graph any vertical lines on a TI calculator, as far as I know. However, if you wanted to see the graph x equals 6 on some sort of graphing calculator, you could also go to Desmos.com. So Desmos, I believe, can give us vertical graphs. So there's x equals 1, and you see the vertical line going through the x value 1. You click on any point, and you see that the x coordinate is always 1. Okay, wherever you are on this vertical line. And x equals 6, there it is right here. The x coordinate is always 6. So Desmos could give you horizontal and vertical lines, but the TI calculator can only do horizontal and non-vertical lines.